Now, let us explain the steady flow energy equation. In the short form, it is called SFEE. That is steady flow energy equation. See here, a process is considered to be a steady flow process when the following assumptions are valid. M1 dot is equals to M2 dot is equals to M. That means mass flow rate entering the system, it should not vary with time and is equal to the mass flow rate leaving the system. It should be there for steady flow process. Then as it is a steady flow, change of energy with respect to time is zero. That is DES divided by DT will be equal to zero because there is no change in energy when it is a steady flow. Now, the previous equation, how I will write here, Q dot plus M dot, because M1 is equal to M2 is equal to M. M I will replace here. M dot H1 plus V1 square divided by 2 plus G into Z1 equal to M dot H2 plus V2 square divided by 2 plus G into Z2 plus W dot. So DES by DT, it is nothing but 0. So I have eliminated that term here, next term. So therefore Q is equals to, Q dot is equals to M dot. So this equation I will shift to this side now. So final equation I will write. Q is equals to M dot, both sides M is there. So here H2 minus H1. So this equation I have shifted to this side. 2 is equals to means H2 minus H1 plus 1 upon 2 V2 square minus V1 square plus G into Z2 minus Z1 plus W dot, as it is here equation. Now for per unit mass, therefore small q is equal to this divided by m means this term gets cancelled, h2 minus h1 plus 1 upon 2 v2 square minus v1 square plus g into z2 minus z1 plus w. So this is a steady flow energy equation. Now let us write down the work done W. So here we have kept W as it is. So let us calculate the work done in a steady flow process. So this is the equation, steady flow energy equation. Q is equals to H2 minus H1 plus 1 upon 2 V2 square minus V1 square plus G into Z2 minus Z1 plus W. So this is my steady flow energy equation. So let me differentiate this equation. Delta Q is equals to H2 minus H1 is nothing but DH plus this is nothing but d of ke, this is nothing but d of pe, d of p is nothing but this equation only, plus delta w of steady flow energy equation. So already we know h is equals to u plus pv. Now differentiating this equation, dh is equals to du plus p into dv plus v into dp. So this du plus p into dv is nothing but delta q as per the first law of thermodynamics. So dh is equals to delta q plus v into dp. Let me call this equation as equation 2. So now based on this equation, from first equation and second equation, delta q is equals to, so dh is replaced by delta q plus v into dp in this equation. dh is replaced by delta q plus v into dp. Rest all other equations I have kept as it is. So in this equation, neglecting this kinetic energy and potential energy, so delta q is also here, delta q is also here. These both gets cancelled. So my equation only remains v into dp plus delta w of steady flow energy equation. This is work done during steady flow energy. Therefore, delta W work done during steady flow energy, steady flow will be equal to minus V into dP. So therefore, delta W work done during steady flow, it is is nothing but minus V into dP. Now, while writing the steady flow energy equation, we have added the flow work. You can see here. So this is the mass, it is having some length dl, so it is entering with some pressure. That means here you can see here work associated with the fluid mass flowing into or out of an open system, it is called as the flow work, and it is applied only for an open system. So now delta w, that is flow work, this dw flow means flow work. So when mass is entering the system, when mass is leaving the system, some work is associated with the fluid mass, so that is called as the flow work. We have to consider it. Can see here, uh, P into A. That means with some force, this mass is entering inside the system here. So force into distance. So force is replaced by P into A in order to push this mass, that is dm, throughout this length inside the system. So some work is produced there. Work, how it is calculated: force into distance. Force is nothing but pressure into area into dl in order to move this much distance. So area into dl is nothing but dv, change in volume. So P, area into dl, is replaced by dv. So dw of flow work, this is nothing but P into V into dm, because already we know specific volume is nothing but is replaced by V, dv by dm, that is volume per unit mass. So therefore change in volume dv will be equals to V into dm. So this flow work per unit time, this will be equals to pv into dm by dt. So therefore work flow, that is flow work, will be equals to m1 dot into P into V. M1 dot is nothing but mass flow per unit time. So it is replaced by M dot P into V. If the if the flow is taking place from point 1 to point 2, then it is replaced by M1 P1 V1. That only we have entered their flow work. Now applications of SFEE equation. So for air compressor, so how this SFEE equation becomes? Because in the air compressor, some work is done on the system, because air is our system here. So some work is done on the system, then only air gets compressed. So at that time, heat is transferring from the system. So when heat is leaving the system, then we are considering heat as negative here. And some work is done on the system means this work done W will be negative. The same equation I have written here, only signs will be changed here. Now steam turbine. In the steam turbine, work is done by the system, because work is done by the system in the steam turbine here, and at the same time heat is leaving the system. So here heat is rejected from the system means it is considered here negative. Work is done by the system, here work done is considered as positive. So I have considered here plus. So rest SFE equation, it will be remains as it is.